Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we will begin with analyzing VoIP traffic, and we'll specifically pick up SIP and RTP and look at a two-caller conversation. Okay, so before we begin, it's kind of important to classify the different kind of traffic that we are going to encounter in this course. So as we mentioned, our focus is going to be SIP and RTP. And there are four cases depending on if SIP or RTP or both are encrypted or not. So the first case which we have is SIP and RTP, both are unencrypted. Then you have SIP encrypted but RTP is not encrypted. And then SIP is not encrypted but RTP is, and that's actually called SRTP or secure RTP. And then finally, both of them are encrypted. Now, depending on the network, you may actually end up seeing a combination of all of these. Basically, in different networks. So, one network could be SIP RTP and the other could be SIP plus SRTP. Now, for each of these, we will also look at different samples. So wherever applicable, we'll look at voicemails, two-caller calls, conference calls, and then finally SIP messaging and DTMF. Now in this video, our focus is going to be SIP and RTP, and we are going to look at a two-person call. So on the server side, the configuration really is that we've set the transport layer to go ahead and listen on all interfaces, and it'll use UDP. And media encryption is actually set to none. On the client side, we go ahead, mention the IP addresses, and along with, again, make sure that media encryption is disabled and transport is UDP. Now at the very end of this course, there'll be a couple of videos on how you can create your own home setup. But for this class, I already have a pre-created PCAP file which we will use. So right now, what is the scenario? We have Bob and Alice, 2132.20.1, and they communicate via the asterisk now server in between, which is at 20.130. Now, before we begin analyzing this conversation and understanding how everything weaves in together, let's go ahead, use a simple block diagram to understand what is it that we want to learn. So we have Bob, we have Alice, you have the voice server in between. Now, the most important thing here is that there are four streams which are responsible for a two-caller communication. So the first stream is really between Bob and the server, and the second stream is server to Alice. The third stream is going to be Alice back to the server. And then finally, stream 4 is server back to Bob. Now, why this is important is that when we look at encryption of RTP with SRTP, what you'll notice is that each of these streams are independently encrypted with a different key. And this is important because we'll have to deal with every stream separately. Now, as far as the port numbers are concerned, between Bob and server, they'll have to go ahead and decide which ports to use for voice data communication. And the same is between server and Alice as well. Now, note that this, what I'm talking about right now, is either RTP or SRTP, right? Above this, and then after the call, is done and they want to end the call with a bye message, you really have SIP. Okay, so now let's actually jump in. I apologize in advance, this is going to be a long video, but I'd like to go ahead and cover all the basics in one sitting. So I'm going to launch a command line prompt. We're going to go inside the VoIP class directory, and then we go into the sample calls directory, and then into SIP RTP. And let's open up normal call two parties. So we see that this actually has SIP, there's also RTP in here. Now what we've done is we've actually put in captures both between Bob and the server and Alice. Now in the real world, of course, you'd probably be only collecting on one side, but because we are still understanding this topic in great detail, it is important to know what is happening on both sides. So to begin our analysis, I'm going to click on telephony, SIP flows. I'm going to select all the flows. Click on flow sequence. I'm going to bring this down a bit, close this window. Widen this up a bit. Okay. So the first thing to notice is, Bob is 20.132 and 20.1 is Alice, and this is the server in between. So we can clearly see that the phone is actually registering. This is Bob registering, and then you have Alice registering here, right? And when you select any packet over here, the corresponding packet actually gets selected in the traffic pane, like we saw in the last video. So the phones get registered. Scroll down here, and let's actually start with the call getting initiated. So we can clearly see that the very first packet is an invite packet, which is going from Bob to the server. And really this is to initiate a call with Alice, right? So they actually end up talking through the server. Now, if you remember, port 5060 was the UDP port number that we had actually set up. I think, was it UDP or... Yeah, this was actually UDP, which we had set up. And you would actually notice that, let's bring it down here. This is the first invite message from Bob to the server. The server immediately sends back an unauthorized. And the server basically says, hey, you know what, I don't know you. Go ahead and authenticate yourself once again. And what you notice is in this message, and I'm just going to go ahead, put up a filter here for SIP or RTP, just so that, we don't have to see all the other messages. So I'm still selecting the 401 unauthorized message. And what you'd find is that inside this message, the authenticate header is actually being sent back to the client, right? So the client then sends an acknowledgement which doesn't contain much, and then it reinitiates the invite message. But this time around, it makes sure that it is responding to the authentication request. So all the message digest stuff that we've seen in a previous video is actually happening here. And in comparison, if you see the first invite message with the client had sent, the first invite message the client had sent, that actually does not contain anything, which is, there's really no authentication of any kind. Okay. So now the client sends it, and because the authorization and authentication succeeds, the server now goes ahead and basically tells the client that it's going to try ringing Alice, and then it goes ahead and initiates a connection out to Alice. So if you notice, this invite message now is actually from the server to Alice. So we can see it right here. Here we go. Now let's scroll down a bit. Now after that, Alice receives the message, her application sends back trying and ringing. We can see this here, right? We have trying, we have ringing. And this is actually forwarded to Bob as well, simply because Bob needs to know that there is some progress being made. Now, once Alice picks up the phone call, her application sends a 200 OK SDP message. The server acknowledges that to Alice and then sends a 200 OK SDP to Bob to actually tell him that the call has succeeded and Alice has decided to pick up the phone. Bob acknowledged that with an ACK, and then he sends an update SDP message, which he receives a 200 OK for. Now, after that, what you'd find is that we have RTP messages. So if you were to scroll down, RTP. So this is containing the actual voice data, and this is actually going now from Alice to the server, and then the server is forwarding that back to Bob, right? And then Bob sending voice data to the server, which gets forwarded back to Alice. Now, even though you can currently only see these 4 packets, there are actually a bunch of other RTP packets in here. The slip flow interface, which is actually there, which is what we are using here, only shows you the first couple just to tell you that, hey, you know what, there are basically these 4 flows, right? As you can see, there is 1, 2, 3, 4, right? Now, after the call is complete, and you can see there are a lot of RTP packets in here after that. But after the whole phone call has been completed, one of the callers is going to generate the bye message to indicate that the call is over. And the server acknowledges that. And after that, the server forwards the bye to the other caller who also acknowledges it. Now, once this is done, basically the call has been completely torn down. Now, after that, as I mentioned in a previous video, we may actually see the phones go back and re-register, telling the registry or the server that they're available to receive calls. Fantastic. So this is how you can take a SIP flow sequence and actually map it to the packets. Now, my recommendation, having worked with VoIP traffic for quite some time, is use SIP flows as the definitive way to start navigating VoIP traffic. If you are going to look at individual packets, you're only going to be confused. Okay, so now let's actually look at some of the other things which we were discussing. So the idea that there are 4 streams is clear, right? Stream 1, stream 2, stream 3, stream 4. Now, in this case, because there is no encryption, everything is fine. I mean, we really aren't even counting the streams. But how can we see that there are 4 streams? So let's go back in here. Let's close this. I'm going to once again click on telephony, RTP, and then RTP streams. And what you'd find here is that we have these 4 streams. Now, keep in mind that this PCAP has been distilled down to ensure that we only capture one single exchange between 2 callers, right? When you're going ahead and mining traffic, you're going to be getting a lot of data, and which means you're probably going to get many streams from many callers. So you will have to make sure you apply those filters, etc. Now, what you'd notice is that the streams, they have a source port and a destination port, and they have something else called an SSRC. I'll come to what this is. And after that, you have the number of packets in the stream, a couple of other things. So let's actually go in here and understand how to look at these streams. So I'm going to once again go in here, click on SIP flows. Okay, and now I'm actually going to go all the way over here to when the call has just been initiated. So here it is, the invite SDP packet. Now let's actually start looking at what is actually in there. So SDP is basically the session description protocol. And this is actually used to describe the session. So SIP actually internally is carrying SDP. And SDP has a lot of parameters required to set up the session correctly. So if you were to look at the first SDP packet, and this is basically from Bob to the server. I'm going to remove this pane. what you'd end up finding is there are a bunch of parameters in here. You have codec information and whatnot. But if you wanted to locate the port numbers which are going to be used, then you should look at media description. So what you'd notice here, that Bob basically tells the server that, hey, when I'm going to use RTP, I'm actually going to use port 4000 as the source port, right? So this is actually sent back to the server. And what you would notice is that when the actual exchange begins, RTP, then Bob is using port number 4000, as you can see, which is also mapped in the flow sequence diagram. You can see that clearly here, port 4000, right? Now it is important to note that I'm talking about RTP. All these SIP messages still before that are actually using some random port on the client side, and on the server side are using port 5060, which is what we had configured on the server. If you remember in the slides, I showed you the configuration, right? So now let's go down here. Okay, so if you were to select the SDP packet, as I said, from Bob to the server, we can clearly see that they have chosen port 4000. Bob has chosen port 4000. Similarly, if I were to look at the SDP packet, basically going from the server to Bob, and that's actually the 200 OK SDP packet. This is it from the server to Bob. You would actually see that the port number being requested is 12262. So this is the port number the server plans to use. And if you just scroll down, you'll actually see that this is the port number the server is using to send and receive data packets, or rather RTP packets, from and to Bob. Similarly, what we have is SDP packets between Bob and Alice. So, the server and Alice. So if you notice, this is the invite SDP from the server to Alice. And the server tells Alice it plans to use port 17004, which is really what it ends up using here. If we just scroll down a bit, there you go, 17004. And then Alice, in her 200 OK message back to the server, says that she wants to use port 4000, right? It's a very common port for VoIP traffic, RTP traffic. So 4000, right? Most of the times you might end up seeing 4000, but nothing stops a client from changing this. So now what we have established is there are these 4 streams, and we've also established how port numbers are being dynamically chosen. So actually firewalls on the edge, they look into these packets, and even they can figure out these associations and actually know which outbound ports to allow, right? Okay, so now the last thing, how do you identify each stream? So what you would actually find is that if we pick up the RTP direction, so let's actually pick up for Bob to the server first. So here it is, Bob to the server. What you would notice if we look at any of the RTP packets is that this has a little field called synchronization source identifier, right? Here it is. Now this field is really important because for a given stream, it ends up remaining constant. So if you wanted to just look at all RTP packets going from Bob to the server, and you identified that the synchronization source identifier is this value, all you have to do is apply a filter for this. And now if you were to look at all of this traffic, you'd find that all of these RTP packets are going from 20.132 to 20.130, which is Bob to the server. Now, let's actually remove this filter. Now, similarly, if you wanted to look at from server to Bob, select that on the flow sequence, go back on the packet pane. Here is the RTP packet. Apply a filter on the source identifier. I have no clue why it isn't allowing me to select it as a filter all of a sudden. Yeah, there you go. And now you can see all traffic, RTP traffic between the server 130 to Bob. Now, again, similarly, you could actually find out between the server and Alice. So here is Alice to the server. We'll have to make sure that the filter is gone. Alice to the server, we can see this has a different SSRC. And then server to Alice, a different SSRC, right? Fantastic. So far what we've actually learned is that we can very easily figure out all 4 streams. We can figure out the port numbers so that we understand how all of these entities are communicating over the network. Now, last but not the least, where is the voice data? Right, so all of these pains is really to make sure that we can listen to an actual phone call, right? So you're probably wondering, where is the actual phone call? So many ways to do it. You can click SIP flows, select, click on play streams, and this will actually open up all the 4 streams. Now, I'd like to caution you that Wireshark is not really an audio player. So a lot of times you'll see that this interface can be very sluggish when you try to play it. So the important thing here to note is that we will talk about other ways to extract this audio out and listen to it on a regular player. For what it's worth, might as well listen to it. So I'm going to hit play. So let's listen to the conversation.
This is caller 1. Welcome to Pentester Academy.
This is caller 2. Welcome to Pentester Academy.
Right, there you go. Again, I have made sure that I don't lose any chance to shamelessly promote Pentester Academy every minute. Now, if you wanted to look at just each of the individual streams, you could do that as well. If you just select it, it'll tell you the source is 132 to 130. Here is the second stream, here is the third stream, and the fourth stream, right? And could hit the play button. Let's give it some time. If you notice now, this has become like sluggishly slow, and this is to be expected. So don't worry if this is happening. And again, as I said, it didn't kind of end up playing properly. We will solve all of these in the course of this entire series, and it's important that you understand that you are going to face this again and again and again. Now, the other way to look at all these streams is to click on telephony RTP streams. And then you could look at these streams individually. So you can click on any of these streams, click analyze, and then click play streams. Now in this case, only that stream is actually shown. And again, you could try to play it. And if this is sluggishly slow, it is to be expected, right? As I mentioned, you will see this a lot. And in the next video, I'll show you 2 techniques by which we can easily take out the audio from the packets. So I'm just going to close this. Well, that's all I had in mind for this video. We've learned a lot. I know this has been a very long video, but I really wanted to look at all the important things in one sitting. And in the next video, we'll look at how we can extract audio using the simplest possible technique. And as we move along, we'll look at other techniques when we come into encryption. So that's all. Thank you. Please recommend Pentester Academy if you have been enjoying my videos.